Okay, so in today's talk, we're going to be talking about REST catalog security. Uh, in particular, some of the strategies that go around it. How we've started talking about it the last couple of years as it's evolved. Some best practices, how we at StarRocks implement it. If that's of interest to you, hopefully it is if you're tuning in. And then we'll go into some of the details of implementation. So let's jump in. So agenda, as I kind of mentioned, we're going to talk about what is the Iceberg catalog or the REST catalog. And then after that, what is the purpose of securing the REST catalog? What's the point? We're talking about it. Why care about the security around it? Some of the challenges in security. So, what are some of the challenges particular to REST catalog, but also some overlap between non-REST situations as well? And then some strategies and architectures in REST security, as I'd mentioned before. So, what is the Iceberg catalog? First and foremost, what about the Iceberg REST catalog? They're not exactly the same thing. Uh, so, the catalog itself, at a high level, is pretty much a front door to your Iceberg tables. It holds the current metadata pointer to your metadata layer and their tables, without getting too crazy into the details, because this is not a particular Iceberg architecture webinar. On the right hand side, you can kind of see where it sits with respect to the rest of a stack. So you have the Iceberg catalog, you have the metadata layer, and you have the data layer, which actually has the data file sitting there. But it roughly answers, where is my table X and what is its metadata, right? Started with Hive, and it expanded over to Glue, Nessie, JDBC. These are all kind of the catalogs that we're familiar with now. And then, I think this was around 2018-ish. Then everybody started implementing their own spec. They said, okay, this is just a metadata pointer. This can probably be implemented a million different ways. And if we have a million different services, we have to implement it in our own way. But there was a big problem with that, because as people started implementing their own methodology to connecting or using the Iceberg uh, catalog, uh, you have dozens of connectors with catalog specific code. So for every single catalog implementation, talking to the catalog, you kind of needed a different client library. Say you're using a Java or a Python setup versus, say, a Spark setup. If I was a user who just loved using Spark with Glue, but my colleague liked mixing Spark with his JDB client or something like that, that would be different client environments that I had to configure. So you have N engines, M catalogs to choose from. And ultimately it becomes a combinatorial issue where you have N times M implementations you have to deal with. And at the enterprise level, it you know gets messy very, very quickly. So for lack of a better word, you had poor multi-engine access. So Bob and Jane can't use the same engine catalog combo easily. That gets into language barriers, depending, as I mentioned, what language you're using, what client are you using, and it just leads to more operational complexity that's unnecessary. So some smart people got together at Apache Iceberg, and along came the REST catalog. Now, what is the REST catalog? They were thinking, is there a way we can kind of universally talk about contacting the REST catalog that's agnostic to every single client? Well, there actually could be a universal spec, and that was the REST API spec. This is something that is exposed across a bunch of HTTP endpoints in a single configuration that's universally understood. So when you have an HTTP spec or an HTTP endpoint, you don't really need to reinvent the wheel for every engine and catalog. You have standardized operations, it's language and engine agnostic, and you have very, very lightweight dependency management. You don't have to start injecting crazy code into the Apache Iceberg repository, and you don't need to bloat your code base unnecessarily. You just have this, HTTP spec, and you're kind of done, right? So with that, to that end, we saw the likes of REST catalog providers like Gravitino, Nessie, Lakekeeper, Polaris, where Nessie and Polaris are kind of combining now. But you had these things show up where they provided a managed catalog, a REST catalog solution, so you could handle it a little bit easier. So that is kind of like what is the catalog, what is the REST catalog. Now, why secure the REST catalog? Well, first, let's talk about some of the risks. So what is at risk when you don't secure it, right? Well, one is compliance. If someone gets unauthorized access to your REST catalog, they could list all of your tables. As I mentioned, it's a metadata pointer, right, to your tables. List all your databases, tables, schemas, find out pretty much the exact path and location of where your data sits if they're smart about it. And living in an age where you have GDPR compliance, in the EU, SOC 2, HIPAA, depending on what industry you're in, you have all these different regulatory policies and agencies that are auditing you. If you're an enterprise, if you don't secure the catalog, you're putting yourself at a huge risk just at the compliance level. Second one being multi-tenancy. So what do I mean by multi-tenancy? Well, a lot of organizations run one catalog that serves multiple teams in a multi-tenant setup. So if we don't ensure isolation or team delegation for one of those teams and enforce credential policies for that one team, the other team can, let's say, the marketing team, we don't want the marketing team, the business analysts, and the developers probably, having access to the same tables, the same schemas, right? So we need thresholds. We need to safeguard it in an environment where we have multiple groups of users. And the third is that your security is multi-layered. So, you might say, I'm good. Actually, no, before getting into that, what is multi-layered security, right? The catalog is just one component of multiple steps of your security, because you have, your security at the cloud provider level, and you may be integrating that with your own file systems. And then you have this catalog level security where it's closer to the user. So the catalog security boils down closer to the metadata level, while the cloud security is usually more file level based security, like IAM permissions, that sort of thing when you're dealing with the cloud. So you might say, I'm good. Let's say you don't secure the REST catalog. Like, okay, I have IAM permissions in AWS for my S3 bucket. Why does it matter? Well, what does it matter if they can use my bucket? Let them list whatever tables they want. That's fine by me. Let them go through the catalog. They'll never get to the files, right? Well, in that situation, they may very well get to see the path or the execution path of where your tables lie, right? And that now tells the attacker where to focus his efforts. It's a multi-layered setup. You can't just secure one and ignore the other, because you need both of them to be tight-knit and take all the measures that we can across the stack. So that's what's at risk. Now, with that risk, what are some other challenges in REST security? One being, I'm just going to briefly go over these and then go over them in depth. So one is authorization at scale. And a lot of these kind of speak to themselves and what they are: fine-grained access control, credential lifecycling, and multi-cloud complexity. So now I'll just briefly go over what each of these are. Now, auth at scale. What is auth at scale? Auth at scale, that is where obviously we're catering to a big user environment at the enterprise level. So when you have auth at scale, multiple engines, traditionally, in traditional senses, multiple engines need user authentication, right? Now, the traditional approach may be, maintaining separate user accounts for each engine, right? Now, what does that cause? Well, you have new employees, you manually provision them on a per engine basis. Say that's across 5+ systems, right? Well, then you get into a situation where you have zombie accounts sitting in your engine. You may have some zombie accounts sitting at the cloud provider level, and you get into the whole mess of password resets, multi-factor authentication, enrollment, role changes. They have to sync everywhere because it's proprietary to the engine, and you have another set of permissions in your cloud. So auth at scale, we want to be able to be in a situation where we can scale seamlessly and we're not relying on this individualistic approach to each layer of your access, right? So that's kind of like what authorization is at scale. And ideally, you have something like an LDAP that's universal, or Kerberos that's universal, where you're not just relying on native accounts and having them clash. You want some universal provider, ideally. Now, fine grained access control. What is fine grained access control? What are some of the challenges? Well, you need permissions at multiple levels, right? As I mentioned earlier, the catalog space is more, or the catalog security is more metadata related. So, namespace, table, column, row, that sort of thing. In the traditional model, each engine kind of maintains its own permission system. Uh, and when each engine kind of has its own permission system, whether it be like a loosely coupled external permission system that's kind of tied or proprietary to that engine, you get into a whole another mess of not having a central truth for who can access what. So it kind of boils back down to having engine-specific implementations that make life difficult, right? So the engine level permissions don't actually reflect the actual data sensitivity. And then I would say one of the most important is credential lifecycling. So this is also a challenge when in not really just in security or REST security, but in security in general. If you have, say, like a long-lived cloud credential, as is the case with many REST catalog providers, hard coded in the engine configuration. Well, one, you have a very high trust of your users, and you also have a very high trust of your engine because you're basically granting it these long-lived credentials that ideally should be temporary, right? And so when you have each engine storing these credentials, you get massive credential sprawl where your credentials are sitting kind of as like a God user on this engine. And those credentials will end up living forever unless they're manually rotated, and unless you have some good policies in the cloud, which hopefully you do. Many times those credentials aren't rotated until they have to be or something happens. So that is the credential lifecycle challenge, I would say, as well, which I would say is maybe one of the most important, if not the most. And naturally, if the engine is compromised, attacker gets kind of permanent storage access because you have these godlike credentials. The last one is multi-cloud complexity. So what is multi-cloud complexity? Well, as the diagram kind of shows, in today's age, we're not really living in a spot where we just have one cloud. You could be using AWS for one service, your Oracle, say for your database, your databases could be completely managed in the cloud. You may have Azure for some enterprise level, who knows, file management, SharePoint. There's a million different things that are going on today in an ecosystem. You're not usually relying on one. So as you're scaling, and just to mention another, like say Confluent, you have another cloud provider just dedicated to your data infrastructure. So a bunch of different things you can be using. So with that data spanning across these different things, the security doesn't end at the catalog or engine. I briefly discussed this a little bit before, but you have kind of the multi-layer security. So you have the security in the cloud. You have, say, your permission system there, whatever your cloud provider is using, but you also have the catalog level. And different permission models, they can clash sometimes. Not everything is universal. As with the example here, S3 bucket policy is not the same thing as Azure RBAC, nor is it the same as GCS IAM. They're going to be using different configurations, different setups, just because inherently they're not on the same environment. So your goal is to simplify the REST layer, simplify the catalog layer, so that it's easier to interact with all of these different clouds. So that is, I would say, some of the challenges and some of the risks that go in with attacking, the REST catalog security. So, what are some strategies and patterns now in REST security? Well, we have two primary modalities, I would say. So one is the query engine client compute enforced permission. So what does this mean? So just to set up the stage a little bit, the query engine client compute enforced permissions is where your permissions are being enforced at the query engine level. Now I have a couple of these, I guess diagrams set up for different parts of your ecosystem when it comes to REST security. So what do I have at the bottom? I have the query engine. I have the StarRocks logo. At the top, I have some identity providers, say like a Ping ID and Okta. In the middle, I have a REST catalog provider. And on the right-hand side, I have an external permission system, say like an Apache Ranger or an open policy agent that could sync in with your REST catalog. So what are compute enforced permissions step by step? So first, what do? We use client credential flow. Now, when your compute is enforcing the permissions, what will usually happen traditionally, and this is common across, say, catalogs like Polaris, Nessie, is you'll use something like a client credential flow, which is a type of authorization flow in OAuth. So I expose a client ID and I expose a client secret. So I take the client ID and I take the client secret and I send it over to my identity provider and say, okay, this is me. You can trust me. Now, is this the best practice? We'll see in a second. But I give the client ID, I give the secret, reaches the identity provider, and the identity provider responds back with the JSON token or a JWT token. Could be it's some sort of token that we receive back that gives us permissions then and validates who we are. Usually, we'll have set up this client credential in secret behind the scenes in our IDP or identity provider. So we get this JSON token back. And it says, okay, yes, you can talk to your catalog, you can execute some specific actions. Now, I pass that token to my REST catalog provider. And the key thing here to understand is that I'm passing the token as a super user. That in itself, I'm sure you could probably already understand, is not ideal, right? I'm getting basically a godlike token that allows me to act as a super user on the catalog. Why is this the case? Well, because in many cases, the catalog implementation may only understand super user based access permissions or credentials. Now, I pass the token as a super user, and then what happens? Well, then the REST catalog uses that token and sends it back to the IDP and validates the token. It says, okay, there's some token that was sent earlier. Can you check, my IDP, whether this token's, it exists? Is somebody spoofing this token? Is somebody pretending to be the super user? IDP responds and says, okay, we're all good. That is your token. This person is actually the super user. Sends it back to the catalog provider. And that token is validated with the permission system. Okay, I have this token now. Given the permission system, what can this super user do? What is this super user capable of? And in this case, the super user is capable, in most cases, of doing everything, no matter who is logging in. So you see at the bottom on the left side, you have whoever Bob and Jane accessing. Doesn't matter who they are, they will be going through the super user process. So then I take the validation token from the permission system, and then I receive vended credentials back from the catalog, whatever catalog that may be. Take the credentials, send them back to my query engine. In this case, let's say it's StarRocks, could be any query engine. And I get these vended credentials. These are the long-lived storage credentials that I was talking about earlier. So these storage credentials sit for whatever infinite amount of time that we set it to. In many cases, we may not even set something up, and we take those vended credentials, and then after we have the vended credentials, we then check permissions for the super user. So that earlier, we just validated whether the token was valid with the permission system. We check permissions with these vended credentials, and then once we get confirmation on the permissions for the super user, we have to realize that this is a query-specific translation because we have to set an integration up with this external permission system to understand what its permissions are for the super user. So this is query engine specific. This is not some universal spec. This is nothing that is built into the catalog. I'm basically going around the catalog to check the permissions for the super user. The only thing earlier at this validate token step was just to check whether the token is valid for the permission system. There wasn't any permission checking happening earlier. That is happening now from the engine to my external permission system. And then, once I check the permissions, then I can finally retrieve data. In this case, let's say it's like a bucket that I have. So that is compute enforced permissions. Now, given that that's the case, this is not obviously ideal because we have implicit query engine trust, and we're giving the query engine pretty much access to the whole house. Um, that is one aspect, and two, it's query specific. So in Iceberg, in the REST catalog, we want something universal, right? So implicit trust, whole slew of issues, and two, it's query specific. So what could be an alternative? Now that this is kind of used across, still used across the industry in different shapes and forms, what do we want to strive towards? What can we get to? Well, ideally, we want to approach catalog layer governance and security. Now, what does catalog layer governance security provide us? Well, it gives us consistent authorization across engines, and it gives us secured and simplified storage so that we don't have to, one, have implicit trust in the query engine, and two, have all of these different implementations of this query translation layer to actually understand our external permission system, right? So these are what we would like to strive towards: catalog layer, governance, and security. Now, we can actually get catalog engine governance security. So this would be the ideal situation, right? This is something that does, in theory, exist based off of the RFC. You can, I can throw them in at the end of this webinar, but based off of the RFC for token delegation, which is more of a newer RFC, we can actually, instead of acting as a super user, we can impersonate the user who's actually sitting at the end, in this case, the query engine. So in catalog enforcement permissions, which, like I said, in theory does work, and I'll explain in a little bit why it's not completely adopted yet, this changes things a little bit. So instead of me sending a token to the identity provider saying, "Hey, I'm a super user," what changes now is I may have this client ID set up on the query engine side, but I also may be using an additional flow, like a client authorization flow, maybe an authorization flow, which is also an OAuth flow, and passing in that token as well to the identity provider. So I may be passing a couple tokens, but what do I get by passing some additional context to the identity provider? Well, then, given that I'm using, say, like an authorization flow, the user, in that case, might receive a callback or a link or verification, multiple ways to do that. But if I am able to pass in some token that acts on behalf of this specific user, and some context for me using the query engine, I can then get a token back, a JSON token. In this case, we receive the token back at the query engine level. Now we have a JSON token saying, yes, I am user A or I'm user B. So this is the main thing with token delegation, is that we can now act and impersonate the actual user rather than having super user godlike credential. So then we have this token representing us. We pass the token as user A to the REST catalog. We validate the token again with our identity provider, whatever that identity provider may be. Now, then we, in fact, go back to the permission system. We validate the token. And once we validate the token, we get vended credentials. Now, in this case, temporary vended credentials, and then check permissions for user A directly at the catalog level. Now, given that we're not actually checking permissions and having this query specific translation to this permission system, we're using the catalog as the governance layer and the one authority on who has permissions. And so there's two main things, right? One, I'm validating myself as a user A. And two, that means I'm not having super user credentials. And two, I'm not using a query specific translation with this external permission system. And then I can get some temporary vended credentials, and then based off of that, I guess that's the third thing, right? Temporary vended credentials. Though the vended credentials ideally shouldn't be long lasting. Then once I have that, I can go ahead and retrieve the data from the object storage. Now, what I just explained here, this is in theory, this should work, and uh, it is implemented by some folks. So Lakekeeper has an implementation of this with a couple of query engines, but it's not widely used yet, mostly because the RFC for token delegation or token exchange is not as widely implemented for the catalog sitting as the sole authoritative uh, entity that's giving you validating your permissions. Now, transitioning over to what we have done. So okay, yeah, there we go. What we have done at StarRocks, before I jump into that, let me just explain, where we sit as StarRocks. So for those of you who don't know, StarRocks, we're a OLAP database meant for real-time analytics, designed for sub-second queries at scale, designed to meet your SLAs, on-the-fly joins, no denormalization pipelines. A lot of folks are out there normalizing their data, exploding, data explosion, disk explosion. We're not about that. Real-time data, mutable directly on columnar storage, SIMD optimized in a storage compute separated architecture. So just to introduce us a little bit, that's who we are and where we operate in the space. Now, I jumped the gun a little bit earlier, but given that that's the case, we have the compute enforced permissions and we have the catalog enforced. In our most recent StarRocks update 4.0, you guys can read about it. We posted a bunch about it on LinkedIn, on our Slack, which I encourage you to join. In our recent 4.0 launch, we actually transitioned over to using catalog enforced permissions. Now, not using this token exchange protocol, but instead using JWT token or JWT token session-based catalog enforced permission. So pretty much the same thing, but instead more secure with a JWT token that gets signed. So how does that work? How are we changing the game and implementing something that at this point is not widely introduced to the industry when it should be? Catalog should serve as your main authority. So how does it work in 4.0? So as I mentioned, we use the JWT token session bearer flow. Now we go in, you pass in your JWT token, which would be pre-signed with your identity provider. That pre-signed JWT token that could be sitting at a user's local on their computer. It could be sitting directly linked to your own identity provider system that handles token signing. You pass that JWT token over to your REST catalog, and then once your REST catalog receives the JWT token, then you can validate that token directly with your permission system, and then receive temporary vended credentials, just like as you should, not long-lasting vended credentials. And then once you get those temporary vended credentials, you can immediately retrieve data from your bucket. So what is what is the main benefit of this? Well, it's implementing the theory which I just spoke about for catalog enforce governance and security. So you can sign in your JWT token in advance with your identity provider, set that up, and now you don't have to deal with any super user nonsense. And you don't have to deal with understanding who is actually accessing your database. And in 4.0, we've and from 3.5, we have the option to set up security integrations with your identity provider. So security integrations in StarRocks, be happy to talk more about that. Is how you can actually set up external identity providers with StarRocks. So use any identity provider you want. Talk to the REST catalog provider of your choice, and have secured access to your REST catalog using the new JWT token bearer flow that we set up in 4.0. Now, that is kind of where what is REST security, what are some of the risk challenges, what is widely used in the industry now, how are we changing that? Now, just closing off a little bit, I'm going to talk about maybe some best practices and strategies that we should be following, just in general across REST catalog security and security in general. First one, which I kind of harped on a little bit in this, was having a single source of truth. So your identity provider should be the authoritative source for identities. right? If a user is removed from your identity provider, access should be revoked, across all of the systems that they're responsible for. You can do that if you link, an identity provider, one true identity provider in your enterprise. You should have direct data access, right? Multiple tools, query engines should be able to access your data directly. There shouldn't be like a central compute bottleneck or gateway that shields your tables. This is more of a general industry practice. And you should centralize your permissions, right? So permissions, whether it be table, namespace, column level, defined once and assessed through the catalog, through catalog level governance. And this can be, really, as I mentioned before, it becomes a central authority for permission granting, but it also becomes an authority that can be enforced across multiple tools, right? So you don't get into that situation with Bob and Jane who they have their own, own individual profile, own individual user, but the compute engine treats them as the same user because there's some super user, right? So try to centralize your permissions, have one authority on who's giving out those permissions, and then lastly, have location agnostic security. As your data resides in multiple clouds, multiple environments, permissions can remain unified regardless of physical location. And that should be just a given based off of using a multi-cloud environment or tenant. So see if there's anything else. That is, I think, pretty much everything I had for you guys. Yeah, I mean, we'll see. Feel free to join our Slack. There is a link. I can share these slides afterwards to the RFC that I was talking about on token exchange. That kind of gives you the theory or the new type of OAuth workflow that is being worked on now, especially around or in the catalog spec in Iceberg. And there's some discussions around that on whether it should be involved more directly. But that is pretty much what I had. Let's see if we open the floor now a little bit to some questions. Let me see what we have on that. All right, looks like we got a couple questions. Okay, yeah. So sounds like we want to support both Hive and Iceberg tables. Then Hive Metastore is the only choice. No, actually, we can use different catalog providers for using Iceberg tables. I can actually let's see. I can actually share. One second. We have the concept of external catalogs. Just share this here. We have the concept of external catalogs where you can use any catalog provider of your choice. So you can hook up to say like a Glue, a JDBC. If you have Iceberg sitting in the cloud, then you can use whatever catalog provider you have with the create external catalog command. So that should be viable. It's we definitely don't limit you to just Hive. This public. So is there any documentation on how to set up the presented JWT token flow in StarRocks 4.0? Yes, there should be documentation on JWT flow for 4.0. I can send it in the post. Let's see. Let's see if it's not let me take a look. Since we're here, let's see where if I can quickly find it in the documentation. Yes. Okay. Yeah. So this page should kind of get you started on that. It kind of goes over the JSON token flow specifically with JWT and auth. It should be updated to 4.0. Let's see, what else do we have here? When you introduce the authorization process, you mentioned that catalogs often do the token handoffs based off of user access. How does StarRocks get around this? So, as I had mentioned earlier, so yeah, so that's a good question. So with the with the JWT tokens, because you pre-sign them with your IDP, you don't need the super user anymore. Um, especially when you use the security integration feature that we have built in. So to my knowledge, because we're using the pre-signed token that's sitting on either the users on the user side, the client side, or it's set up with some LDAP system or server side that's linked to your IDP. I believe that is how we get around the super user access, just because we're using the JWT token session. If you have, I guess, more questions surrounding that, I can definitely take it offline and get more information on how we actually avoid it. When do you expect this to be fully implemented? As of now, it should. I mean, the actual token flow is implemented in 4.0. You should be able to use it as users have questions or qualms about specific parts of its feature set. We're more than happy to take questions. Work with engineering to help you guys figure it out. Like I said, it is more of a newer offering in 4.0, but it should be completely fully implemented. Can you say more about Nessie and Polaris merging? Yeah, I know that one of them. I don't know the full details, but I know that one of them has stopped. I believe Nessie has stopped a lot of its development solely just on the Nessie side. I think a lot of their features are coming together, and I'm pretty sure I read some Snowflake sources on that. But I don't know the full details. But I know that I think Nessie is stopping a lot, so a lot or some of its development, and just inheriting a lot of what Polaris is doing. Still interested in the security integration because after several days, it's not working at all. Azure neither works for Auth0 nor JWT. Christian, I'm very interested in where you're going wrong with this. Ping me on Slack, and we can talk about what's going on or how you're using it, and we can sync in some of the engineers to see if they can take a look at what's going on, because I want to definitely security integration should be working as well. So if there's any issues with it, please reach out to me offline on Slack. I can definitely go ahead and answer them. Can you show a demo with this, what I already set up? Yeah, so that is in the pipeline. That is definitely on the list for content creation. There are a lot of users who are interested in this. So expect a demo at some point pretty soon that actually shows the end-to-end of this. Because I know this is kind of a complicated thing for a lot of folks because of how esoteric a lot of the knowledge is surrounding this. Even in our documentation and other folks' documentation on these OAuth flows. So yeah, just definitely stay posted on the demo. It should be coming pretty soon. I think those are all of the questions. If you have anything else, feel free to take it offline, Slack me, whatever. I'm more than happy to front your questions. I just want to be as helpful as possible. If you have any use case specific questions, front them to me. I'll try to get back to you as soon as possible, and work with some of our field engineers to address some of the complaints or questions you may have. So yeah, feel free to join the Slack. The deck for this will be up, so feel free to take a look at that as well. But otherwise, I think that closes out our webinar for today. Thanks for joining. Like I said, if you have any other questions, take them offline. Feel free to send those to me. I'll answer them. But otherwise, have a great rest of your day, and thanks for joining me today on this webinar. It was fun. I'll definitely this is a topic which is definitely interesting to a lot of people are interested by this topic. So definitely we'll try to approach this topic more often. Try to generate more content around it, because this is a big topic for a lot of people. Compliance, security. Try to stay on top of this stuff. But yeah, otherwise, thanks for attending today, and I'll see you guys in the next webinar. Thank you.